Hello everyone, welcome to all of you in Chemistry by Saad. Today what we are going to discuss a very important topic, and that topic is a topical P4 paper for IGCSE chemistry. This is equivalent important for Redoxal chemistry, for O-level chemistry. This is topical paper 4. Let me open that paper. So guys, this is question paper. I will solve this question paper for you. The topic name is acid and base. All right. The topic name is acid and base. So in this topic, if you previously have studied, if you previously had studied about the concept of acid and base in your textbook, then this will be very fruitful for you to solve this topical paper. I will discuss the solution of this paper with you. Let's start without wasting any single minute. Let's start from question number 1. They react with water to form acidic solution. They means HCl and HF here. Explain why water behave as a base in both these reactions. These are two reactions. In these two reactions, HCl is going to react with water and HF, hydrofluoric acid, is going to react with water. So we have to figure out why here water is behaving as a base. The point is, remember the definition of acid and base. Guys, any substance which can donate proton is called acid. Any substance which can donate proton is called acid. So I will write proton donor. Proton donor is called acid. And what is base? Proton acceptor is called base. So here you can see that when we talk about HCl, let me explain the reaction by writing here. This HCl is donating a proton and water is accepting that proton. When H2O, which is a water, will accept that proton, water will convert it into H3O positive, and HCl by donating proton will be converted into chloride ion. So you guys can see that HCl is donating proton, so HCl is an acid, and water is accepting that proton, so water is a base. So I will write why water behaves as a base. Water behaves as a base because water is accepting proton, because water is accepting proton. So this is the answer. All right. The next is, how would the pH of these two solutions differ? Okay. HCl and HF, HCl solution and HF solution. So how would the pH of these two solutions differ? The pH of HCl is quite, the pH of HCl is quite low, because in case of HCl easily lose proton, HCl easily donate proton. So it means HCl is a strong acid, and a strong acid always have low pH value. Remember guys, a strong acid always have low pH. In case of HF will not donate proton easily as HCl donate. When we compare HCl with HF, remember HCl donate proton easily, so HCl is a strong acid, and HF will do not lose proton easily, so HF is not a strong acid. So answer of this question is HCl will have low pH because it is strong acid, because it is strong acid. Okay. HF will have high pH value, high pH value, because it is weak acid. So let me erase all these things. Going towards next question, what is term amphoteric? Amphoteric is quite simple to do. You guys know that any substance which can act as base as well as acid is called amphoteric. So it is very simple to do. Going towards the question number 3, the table shows below the elements in the second period of the periodic table and some of their oxidation states, and the most common compound element are given, number of outer electron are also given, oxidation states are also given. Select two elements sorry, select two elements in the table which exist as diatomic molecule of the type X2. Okay, oxygen. Let me explain this question. This is oxygen. The atomic number of oxygen is 8 and number of outer electron in oxygen is 6. So 1 2 3 1 2 3 4 5 6. So oxygen has 6 electron in its outermost shell. Is this oxygen stable? Not at all. Oxygen is not stable because for stability criteria we know that atom must have 8 electron in their outermost shell. If atom has 8 electron in their outermost shell, that atom is stable. Oxygen do not have 8 electron in their outermost shell. Oxygen has how many electron in their outermost shell? Oxygen has 6 electron in their outermost shell. So oxygen is not stable. So this is another oxygen. This also contains 6 electron in their outermost shell. So what will they do? They will share electron. When they will share electron, then at that time this oxygen atom will contain 8 electron. By sharing, you see, by sharing 1 2 3 4 5 6 7 8. Similarly 1 2 3 4 5 6 7 8. So by sharing, oxygen atom gets stability. By sharing, oxygen atom managed to have 8 electron in their outermost shell, and we get O2. So two elements in the table which exist as diatomic molecules. The one is O2. One is O2. Oxygen molecule. Other is nitrogen. Nitrogen is also behave like this. You see, nitrogen, atomic number of nitrogen is 7 and it has 5 electron in their outermost shell. 1 2 3 4 5. Is this stable? No, nitrogen is not at all. Nitrogen has 5 electron and nitrogen wants 8 electron. So let me draw another nitrogen atom. 1 2 3 4 5. By sharing by sharing these two nitrogen atoms, managed to get 8 electron in their outermost shell, and we get N2. So other is nitrogen molecule. Similarly, fluorine F2 molecule. The next part of question 3 is beryllium hydroxide, a white solid, is an amphoteric oxide. Name another metal which has an amphoteric oxide. Other metal is zinc and zinc hydroxide, zinc oxide. Zinc oxide is an amphoteric. Similarly, aluminium oxide or aluminum hydroxide is an amphoteric. These are the metals. Zinc oxide, or we have to just put name. So just erase this oxide, put zinc and aluminium. These are the metals which are amphoteric oxide. So just what you would observe. Let me move forward. Okay guys, do you have any questions? You can put your question in the comment section. I will try to answer those questions which you can put in the comment section. You can contact me as well as by this WhatsApp number. Okay, now suggest what would you observe when an excess of aqueous sodium hydroxide is added gradually to aqueous beryllium sulfate. Remember, this is question from precipitation topic. We get a white precipitate. If you not familiar with precipitation topic, then I think this will become difficult for you handle such questions. What would you observe when excess of aqueous beryllium sodium hydroxide is going to react with aqueous beryllium sulfate? We get a white precipitate. This is question number 2. At equilibrium, only 1% of hydrogen chloride exists as molecule. The rest has formed ions. In the other equilibrium, 97% of the hydrogen fluoride exists as molecule. Only 3% has formed ion. What does this tell you about the strength of an acid? Let me explain this question. I have hydrogen chloride and hydrogen chloride is going to dissociate into hydrogen ion, then chloride ion, and just 1% HCl remain in undissociated form, and 99% HCl is in dissociated form in the form of hydrogen ion and in the chloride ion. The other is HF. 97% HF remain in undissociated form, while only 3% HF goes to dissociate into hydrogen ion and fluoride ion. What does this means? Okay, what does this tell me about the strength of acid? Oh, what happened, guys? Remember, the acid which dissociated completely, or the acid which dissociate to a large extent, that acid is considered as a strong acid. HCl is a strong acid. HCl is a strong acid because it dissociate into its ions. 99%, while HF is weak acid because it dissociate into ions only 3%. Define the term acid. Acid is a species. Acid is a species which accept proton. Oh, sorry, which donate proton. Proton donor is called acid. Proton donor is called acid. Proton donor is called acid. Next is hydriodic acid. What this term is? Hydriodic acid. Hi is a strong acid. Its salts are iodides. It has the reaction of typical strong acid. Complete the following equation. This is lithium. Let me write this one. Lithium is going to react with Hi, and what happened? I get lithium iodide along with hydrogen. And when we balance this equation, just put a 2 here. When we put a 2 here, then put a 2 here and put a 2 here. Do you have any idea how to balance the equation? Okay. So 2 lithium, 2 hydrogen iodide, we get 2 lithium iodide along with hydrogen. The next is zinc carbonate and hydriodic acid. When this is zinc carbonate is going to react with hydrogen iodide or hydriodic acid. The product is zinc iodide. And the formula of zinc iodide is ZnI2. The formula of zinc iodide is ZnI2. Along I will get carbon dioxide and water. So let me write, this is zinc iodide, then carbon dioxide, and then what is this? This is water. So zinc iodide is ZnI2 and carbon dioxide and water. To make this equation balance, we have to put a 2 here. Okay, guys, everything is balanced now. The third one is magnesium oxide is going to react with hydrogen iodide. The product is MgI2, magnesium iodide and water. So to make this equation balance, put a 2 here. Okay, name two of the reactions in A are acid base and one is redox. Which is redox? Explain your choice. Remember, I have these three reactions, this one, and this one. Among these three reactions, two reactions are acid base and one is redox reaction. So which one is redox reaction among these three reactions? Remember, reaction number 1, I, is redox reaction. This one is redox reaction. The reason behind this is the oxidation state of lithium is 2 here, the oxidation state of hydrogen is +1 here, iodine is -1 here, the oxidation state of lithium is +1 here, and iodine is -1, and oxidation state of hydrogen is 0 here. So you can see the oxidation state of lithium is 0 into lithium +1. So this is oxidation, and you can see the oxidation state of hydrogen is +1 to goes into 0. So what is this? This is decrease in oxidation number. This is reduction. And what about iodine is -1 here, again -1, nothing happened. Lithium, yes. Okay, so oxidation and reduction is taking place in the same reaction. This is called redox reaction. So what should be the answer of this question? Transfer of, we can say that oxidation and reduction is taking place in same reaction, in transfer of electron, or we can say transfer of electron as well. So this is the redox reaction, and this is reason of my choice is. So guys, going towards the next question. Antimony oxide is a white powder which is insoluble in water. Describe how would you find out that is basic, acidic, and amphoteric. Okay. Remember, basic oxide will react. If basic oxide can react with acid, then it means if a substance which is basic oxide, and if that substance can react with acid, it means that substance is basic oxide. If a substance can react with base, it means that substance is acidic oxide. Again, listen, if a substance can react with an acid, it means that substance is basic, and if a substance can react with a base or alkali, it means that substance is acidic. And if a substance can react, and if a substance when react with acid behave like a base, and that substance when react with the base behave like an acid, it means that substance is an amphoteric. So basic oxide react with acid, it means that substance is a basic in nature. Acidic oxide can react with alkali or a base, and if a substance react with acid as well as with base, it means that substance is amphoteric. That substance is amphoteric. Okay. Now the next question is, fish live in water which is neutral, neither acidic nor alkaline, acid rain. Okay, guys, I will solve this question in my next video, otherwise the length of this video will be longer, so I will make this topic in the next video, inshallah. Do you have any questions? You can put your questions in the comment section. Thank you so much for watching that video. You can contact me as well.